Well, hello, everyone. Welcome to another webinar presented by ATG. I'm going to be your host today, Don Rasmusson, and today we're going to be talking about some of the design-based schedules inside of the Mechanical Electrical Plumbing Productivity Pack. The Mechanical Electrical Plumbing Productivity Pack is a tool made by CAD Technology Center at ATG. We are the exclusive reseller of all CTC tools. And so that is why I'm here today to talk about this particular product with this particular feature. So as always, guys, feel free to type in your questions wherever you or whenever they come up. I will do my best to answer them throughout the webinar if they are pertinent. If they are not, I will go ahead and answer them at the end of the webinar. Let me go ahead and close my email so we don't get any more of these annoying notifications while I am presenting to you guys. So hope everybody's having a wonderful day. Let's go ahead, dive into the webinar and get started. So the Mechanical Electrical Plumbing Productivity Pack, it's often asked of me, what is this? It is not a piece of software. It is a tuned Revit environment where all shared parameters are mapped and balanced across all content, schedules, views, everything that you need to operate Revit. Part of what we're able to do, because we went through the process of standardizing parameters, is we're able to use those parameters in a way that really makes schedules extremely powerful. As anybody who's used Revit before, you understand that the nature of the data in Revit is reciprocal. So if I put a piece of equipment in a model and it populates my schedules, if I go to the schedule and change the data on that piece of equipment, the piece of equipment in the model updates, and vice versa. If I update it in the model, it updates the schedule. And so that puts you in a position to use the data that is in the schedule to drive a lot of your design. The first place I want to stop and look is the overload circuit check, which I find extremely useful for the electrical side of Revit. Anybody who's using Revit for electrical, you know that as you're circuiting in Revit, the error will come up and tell you that you have reached 80% of the circuit breaker load. But then it will allow you to go right past that. This circuit rating is a default, or I shouldn't say default setting, excuse me, is a setting that is broad in the electrical settings part of Revit. You can set what your default breaker size should be. You can see right there, my circuit rating is for 20 amps. That is what initiates that little warning that says you put 80% of the load. Obviously, not all breakers that we put in are going to be 20 amps. Some of them are going to be bigger. So what we've done here is we've created a nice little schedule for you inside of the product that allows you to look at all circuits and the size of the breaker. Then some conditional formatting that turns the cells red when they are over the load for the breaker. We also give you the apparent current so you can make good decisions right here, as well as the panel and the breaker count, the breaker number rather. So if I go ahead and look at this particular one right here, I can see I got a 20 amp load. I'm going to go to a 100 amp breaker. I said 20 amp load there. Sorry, guys, 20 amp breaker. I'm going to adjust this to 100 amps and see what happens. Of course, I adjusted that breaker size. That breaker size is now adjusting the panel as well, but I'm still getting my warning that I'm not quite big enough yet. So if I adjust this to maybe 110, still getting a warning telling me that my breaker is too small for 80% of the load. So what happens if I go to 120? Oh, that one's big enough. You can see the conditional formatting goes away. Nothing else changes in this schedule except for the breaker size has changed. And of course, that's been updated in the panel at this point because of the rating parameter. So that's our first stop in some of these design assist style schedules that we're talking about here today. There's some other things electrically, circuit schedule analysis. We'll open up this one. This one is keeping track of all circuit numbers, all power factors, true load, apparent load, and reactive load. So here we can just simply come and do a quick review on each one of our panels to make sure that we're doing okay with our panels. This is just a review style schedule. Of course, if things are wanted to be changed, we can just simply click and change certain pieces of information. Some of the other more popular schedules for electrical are the cost estimate schedules. We have two here for varying values and for fixed values. There is a cost parameter associated with everything that we have inside of the mechanical, electrical, plumbing productivity pack. And as you start adding in the cost to those items, obviously we're counting them up here. We can apply things like the labor rate, labor hours, labor costs, taxes, right? Material costs, QR percentages, so that we're able to kind of get a good estimate on the cost of our design. If you're on the engineering side, this can provide you some value if you're having to review some estimates from contractors to make sure they're kind of in the ballpark. Of course, if you're a contractor, this is a huge help to you in your estimation process. So those are some of the things that we have for electrical. I want to get down to some of the mechanical ones as well. So I'll just scroll down here to mechanical. In mechanical, we have them divided up into two different areas, some specific ones for air terminals and some specific ones for everything else. I want to start with one of my favorites, and that is the design space airflow summary schedule for air terminal. So what you have here is a schedule that keeps track of all the spaces in your entire project, every single diffuser that is placed in that space, the flow rate for that diffuser, the square footage for that space, and of course your calculated values that will populate in this column right here if you're using the GBXML workflows with train trace or carrier HAPs, or you're using Revit for heat loss, heat gain calcs. All those items will populate this column. Of course, the advantage of doing it with the GBXML workflow or with Revit is that we have that calculated value right here. Revit understands where that value is assigned. And so therefore we can use this as a unit of measure to do comparative analysis for our pressure, for our percentage of differences. Huge advantages here, because this in essence allows me guys to come and balance my entire project from this schedule by literally just clicking in a space, applying a value, entering that value. You see that value is added up here to the actual, which is then compared to the total and then compared to the percentage difference. The percentage of difference column we set up to be a range of +5 -5% on the conditional formatting. So that's why you saw the red go away, because I'm in that +5 -5 range. Of course, everything that we've done from a grill perspective in the MEPPP is set to be universal. For example, a 355 FS grill from Titus, right? That particular grill can be used in a lot of different applications. It's just a very simple, basic grill. So by setting the connector on this to be a universal, it takes on the system properties of any system that is either assigned to or connected to. And so therefore, in the pack, it understands automatically when I attach it to an exhaust system that this value that is given as a flow rate is an exhaust value. This schedule then takes the exhaust value, adds it to the return air value. Since this is a restroom, we don't have any return air, adds these two numbers together and subtracts them from the actual to give you the pressure check on the space. And all of this is automatic. Of course, we have conditional formatting on the pressure check cells, so that if it's at 0 and it's a balanced pressure, you can see that it's green. Other than that, it's positive and negative numbers for positive and negative pressure. What makes this super, super powerful, guys, is that when you combine this with the auto sizing capabilities of the diffusers and VAV boxes, this schedule has literally changed the way that I work in Revit at this point. It used to be my 4-part workflow for success in MEP was to select and place your equipment, even if it's just general, define your logical systems, model your connecting geometry on those logical systems, annotate the model, and print. Now, when I get a project with this environment, my first step after heat loss, heat gain calcs is to just simply place my spaces. Well, actually, I should be doing that before my heat loss, heat gain calcs, excuse me. After my heat loss, heat gain calcs, I'll go ahead and place my diffusers. I will then place my VAVs, particular to the zones, and then I'll run duct between the diffusers and the VAVs, and I won't even care what size it is. I just want something that transfers information. And then I will simply come to this schedule and fill it out. As I fill this schedule out, my diffusers are auto sizing. They're pushing all that information back to the VAV, and the VAV is auto sizing. So in filling out this schedule, I have sized all my diffusers, I've sized my VAVs. Now I simply go back to my duct, look at those flow rates, and start sizing my ductwork. And we have some other features inside of the pack that I'm not going to get into for this webinar that really help you make those decisions with confidence, whether you're using the automatic resizing in Revit or some of the tools that we've provided to you through virtue of color legends for ductwork and for pipe for that matter. We have those as well. But some other things that we give you in terms of air terminal design schedules. Here's your diffuser sizing schedule. So if you want to look at specific sizing, all that information is laid out here for each individual part and piece. So you can make sure things are set appropriately, whether it's a lay-in diffuser versus a surface mount diffuser, whether it is bidirectional or unidirectional, right? What flow is there? How is it installed? Is it a surface mount? Is it a lay-in? Is there an equalizer grid on it? You can make all those decisions here. Again, taking advantage of the fact that it's faster and easier to go through a schedule like an Excel table than it is to navigate yourself around the project and click on specific diffusers and change their information. Same thing for linear slot diffusers. We do a little bit more with linear slot diffusers because of the criteria that is required. For example, your CFM per length is a value that you would have to fill out specifically for the auto sizing linear slot diffusers that you wouldn't have to fill out in other places. Of course, we could lock these linear slots into certain lengths and certain row counts. I'm going to scroll down now and talk a little bit more about the other design schedules that we have inside of the mechanical, electrical, plumbing productivity pack. I can see here my mechanical design air property schedule here. Of course, inside of the pack, we have placed that on the starting view splash page. And the reason we've placed that one here along with some other ones is because they're going to control some basic design information for us inside of the mechanical, electrical, plumbing productivity pack environment. So if I come here, this is my design air property schedule. If I'm in here, I can click inside of here and change some information about this particular schedule just by simply double clicking on that schedule, opening that schedule, and now I can change the density of my air for the entire project. Part of the reason we develop these design air property schedules, of course, if I go back, you can see that we have one for gas load as well. Propagating of CFH is something we do inside of the MEPPP, even though it's not native to Revit. But we put these things in here not only so that you could have better control, but also because a lot of these settings are inside of Revit, obviously, but they're buried in a lot of other places. And they're difficult to find. And if it's something you don't do on a regular basis, it's kind of a pain. So we want to give something to you that is much more user-friendly and gives you a little bit more control and hopefully a little bit more confidence in Revit's calculation capabilities. Of course, do the same thing here with design fuel properties. You can set these heating values to be different, whether it's 1690 for liquid propane or it's natural gas at a different elevation. And then, of course, those heating values play a role in propagating your CFH flow for your gas pipe. You can use that CFH flow propagation that we have inside of the pack to help you size your gas pipe. It does not auto size based upon the CFH, but you can click on any pipe that has gas piping assigned to it and see the CFH flow, and then go to your sizing wheel and help you size your gas pipe. We also give you the ability to do your density for heating plant water, cooling plant water, and rejection plant water. Again, affecting your head pressure calcs, bringing more confidence and more clarity to the analytics inside of Revit and how they work, and obviously giving you a little bit more control than you may be accustomed to inside of your normal Revit environment. We also have design airflow in spaces, design airflow in equipment, and design airflow in components. All of the mechanical equipment inside of the mechanical, electrical, plumbing productivity pack can be busted out to be scheduled as component-based or equipment-based. That is completely up to you. Each one of these design airflow schedules works in the same vein, so that If you do bust it out in components, you would use the design airflow component schedule. If you kept it all together in the same piece of equipment, you would use the design airflow and equipment schedule. The design airflow and spaces schedule is a really nice schedule to keep track of just the different spaces. You see, it looks a lot like the diffuser schedule that we looked at earlier, except it's just organized a little bit differently. And it looks at different spaces for you so that you, again, have more space engineering data for your airflow. One of my favorites, however, is Ashrae. We figured out a way to put Ashrae 62.1 calcs in Revit, but unlike what Autodesk has done with it, I like our method a little bit better because it gives you a more full range of control, and it also gives you the ability to edit a lot of the base data that's there. So as 62.1 changes and grows, as there's always amendments to our standards, this can move and grow with you with just a little bit of work. So the occupancy category list is a key schedule that in essence we just pulled from the Ashrae 62.1 standard. And we filled all this information out. And this is what I mean by you can just simply add some things and grow with the standard with this process rather than relying on Autodesk to do that for you. We then took that key schedule and tied it to basically a glorified space schedule inside of Revit. And so what this is doing is this is keeping track of all the spaces, the number and the name, and then of course the occupancy category list that you select that is driven by this key schedule here. And so if we were to change this to something, I'll just go ahead and scroll a little bit and pick something like computer lab, for example. Obviously, it already knows it's 80 square feet. It's pulling that information from the model. But you saw here that when I changed that, my outdoor airflow changed, my rate per unit changed, and my breathing zoning unit changed based upon the key schedule that we created. All I have to do now is tell it how many people are going to be in that space. I'm going to pick an extreme number here. And then, of course, my error distribution of effectiveness. So how do I want to calculate this? At 70%, 80%, 90%, 100%, whatever I want to do, I can do here. As you can see, a lot of it has already been calculated at 80%. I'm going to do this one at 90, put in a 0.9. Then I'll go through and calculate my outdoor, or excuse me, my 62.1 outdoor CFM for that particular space. You can see it does it for all the spaces here throughout the entire project. Of course, we can add all these together for a total to figure out our sizing. This is done per space. Again, we could group these into zones too if we really wanted to look at them at a per zone concept as well. But this is an extremely useful schedule. Of course, as spaces change, areas update automatically. Calculations would be being performed automatically based upon those changes. Room names and number changes, it's automatically updated here. You can see how it's busted out per zones already that we have controlled. So there's a lot of different controls that you have inside of here that you're going to be able to use. They're going to be able to help you understand, at the very least, how to size your outdoor air duct and set your economizers on your units. Some other design schedules that we have that are used consistently. The clearances, we've added clearances to all of our equipment inside of the MEPPP. This is whether or not clearances are seen, and then of course setting the clearance sizes can be used right or done right here rather than going around to each individual piece and setting clearance information. Equipment locations is another design schedule that we have. Again, these schedules are never intended to be on a sheet, right? These schedules are intended for you to use in your design process, be a more efficient designer. You can see here that I've got my description, manufacturer, model number, right? Which schedules they're showing up on. And of course, any overrides that I would want to select, be it space overrides or not. This is the automatic naming, automatic space recognition that it has inside of it. But here I could choose a space override if I really wanted to, type in some different spaces that I want to schedule rather than the space that is just located in the spaces served, however you want to use this. Weight summary. The weight summary is super nice for the structural engineer in your life. They're very appreciative of what our supply and return duct openings are like on the roof, how much the piece of equipment weighs, All that information is here. Of course, if you have a structural engineer who's good with Revit, what's really nice about the fact that we put all these schedules together, everyone, is that when you exchange your model with structural, for example, structural could very easily bring in this schedule, or you could even do more for them and right click on a schedule and say save to new file, which rips this one schedule out and saves it to a new Revit file. They can then put it inside of their project. But once your link is in place, if they have this schedule, all they have to do is come into fields here and make sure they click this button, include links, elements and links. And now this schedule will populate with all of your data. And so if you update your schedule and give them a new link, this schedule will update with the new data. And so it's very reciprocal, very user-friendly, very usable, things that make a whole lot of sense for us inside of our workflows. Other ones on mechanical before I get to plumbing, everyone. Some of my favorites are the motorless. We are constantly in this position where we have to share information with electrical, be it a multidisciplinary firm that we work for, or in the event that we are third partying out, for example, electrical, and we have to share our model with them. We can also share our motor load information with them. So what we have here is an equipment review schedule for electrical. It is under the mechanical equipment category because what we're doing here is we are looking at all the pieces of mechanical equipment in the entire project and deciding whether or not that piece of equipment needs to be considered for an electrical connection by the electrical designer. In essence, guys, is it 120 volts or more, or is it an existing piece of equipment that the electrical designer doesn't need to incorporate into the load because it's already done? We would just simply review this schedule as mechanical designers, scroll down to the bottom here where everything's red like you see here, and just simply say, yep, that air handling unit, that's part of the deal. So once I click that box, the air handling unit goes from this red conditional formatting and it gets placed up here in this schedule where I can fill in certain information for it if I want to, but it's definitely included now in the motor load calculations. Okay? I can then take that and review this motorless schedule. So the equipment review schedule leads to the motorless schedule. You see that I check that, now it's added to the motorless schedule. This would carry pertinent electrical information. With this pertinent electrical information, I could definitely do the same process with this schedule with electrical. Send this schedule to electrical, have them open it up, check the include linked elements box, and then this schedule will populate with all of my pertinent data for electrical loads so they can feel confident in the fact that I have information in there, that it is something that they can circuit in Revit. And of course, some of the NEC 430 lookup tables that we have placed in everything allows the mechanical designer to be able to look at a cut sheet, even though it has only, like, say, for example, FLA or MOCP, set that value and have that read the 430 lookup tables and auto-populate the rest of the electrical values. And of course, we added overrides in here too for electrical designers, so that if you want to introduce a safety factor or you don't like the calculations that have come back as a result of the NEC 430s, you can put in whatever values you would like, and then of course circuit those values as well. So a lot of control there for both mechanical and electrical, and some good workflows to make sure that electrical design can get started earlier on in the process than they traditionally are able to while they're waiting on electrical loads for all the mechanical equipment. And so I will come down here to the very bottom of our schedules and talk a little bit about the design schedules for plumbing. We didn't leave plumbing out in the cold. Some of the things that we have set up for plumbing really do play with the workflows that we have for plumbing placement. If you guys have ever seen anything inside of the MEPPP before, from a plumbing perspective, we use model groups. Those model groups are based upon a hockey puck family that we made as a plumbing fixture. And so what we're looking at here is the settings that move the hockey pucks inside of that plumbing fixture around to match your, say, for example, a bowl flush valve combination or a lab with a trim kit, right? We wanted to make sure that we made those hockey puck families flexible enough that you could simply input XYZ values and move those hockey pucks around to match those connecting locations. But we gave you a schedule so that you can do this in a more centralized manner, again, like filling out an Excel sheet, versus going around to every instance in the model, clicking on it and making a change. We just simply come in here and start moving numbers around, changing numbers. And of course, that is moving connectors in the background, right? The idea would be that we could sit down again with our plumbing fixture cut sheets and start entering data and have everything in the model start updating automatically behind the scenes. We also give you fixture unit summary as a design schedule. The fixture units inside of what we've done are 100% amendable, 100% customizable. We can adjust those usually at the type level is where they ride, but we also give you some instance overrides that especially for pressurized fixture units, so that you could look at those on an individual basis and help you calculate different municipalities' desires for fixture unit calculations. What you see here is that the fact that we've kept track of every single fixture inside of the entire project, what type of fixture it is, how many of them there are, where they're located, room name and number, the sizes for them as well. And then of course, fixture unit counts here and totals down for the building at the bottom so that you can size services more easily. Of course, all this is reciprocal with Revit. But one of the other things that we've done for plumbing that I use a lot of is what we've done for storm drain calculations with design work or design schedule workflows. With storm drain calculations, everyone, what we have done is figured out a way to propagate square footage down rainwater leader piping. The projected roof area that you see here is a hand entered value. And we would love to make this an automated value, but the reality of the situation is that a lot of the architectural models you get don't consistently enough model sloped roofing. So we can't auto-generate a projected roof area per roof drain. If we can get all the architects in the world to be consistent, this would be awesome. But unfortunately, I think that's a pretty tall ask. So what we did was just give you the ability to enter it by hand after you calculate it. This also allows you to, relocate rainwater leaders in the need that you have to. Gives you the most flexibility in essence. But when you come here and you enter that square footage data, that then becomes a piece of information that is flowed down the pipe. So as I take different rainwater leaders and I connect them to a riser, I can then click on that riser and see exactly how much square footage that riser is responsible for, thus helping me size that riser. But another thing that we did was put in GPM calculations like you see over here. And the reason that we did that is because rainwater leaders are becoming much more analytical than they have before. It used to be something like, you just put in your projected roof area, look at your slope, and that sizes your pipe, and away you go. Now GPM is becoming much more of a unit of measure in use for sizing rainwater leaders. And so what I'm going to do here is I'm just going to take this 4 inches of rainfall per hour, and I'm going to change it to 6. Revit's going to say, hey, you can't do that for one rainwater leader. You have to do that for all rainwater leaders in the project. Great. Yep, 6 inches of rain doesn't fall on one half of the building and 4 inches on another. But I want you to pay attention over here to the GPMs. See how they recalculate? Automatic calculation based upon the rainfall inches per hour and the projected roof area. Now, of course, like everything else we've done in the pack that auto calculates, we have an input override value. This input override value allows the engineer or the designer to put in any value they want. For example, you may not want to report 250.3 GPM. Maybe you just want to report 250. I can come here to the input column, type in 250, and you'll see that that value is now reported here. What we did is put an if-then statement in every single one of these overrides. And that if-then statement basically says, if there is a value in the input column greater than 0, take that value and replace it in the calculated column. So what this means for you is that the actual schedule you're going to put on a sheet, you don't have to go back and change anything about it. We don't have to rearrange parameters. We don't have to unhide a column or anything like that. It simply just reports what you tell it to. And that's the biggest reason we put in these input columns, to give you the full functional control. So you can see, for example, here is the actual rainwater leader schedule that we would put on a sheet and purpose. So we've reached that point in the webinar, everyone. Are there any questions out there from anybody? I'm looking at the group chat here, seeing if there's any messages or questions from people coming in about some of these design schedules. All righty, everyone. Well, if there's no questions, we'll go ahead and we'll close the webinar out now. As always, guys, feel free to contact us with any questions you might have around the mechanical, electrical, plumbing productivity pack, or any other other services or tools that we offer here at ATG. Of course, my name is Don Rasmusson. I am the director of MEP Services here for ATG. So I'm here to answer any questions you might have about the mechanical, electrical, plumbing productivity pack. And just want you guys to understand that we're always here to help you, because we do truly believe in the partnership model, and we want to be your partner in success inside of your daily ventures at your place of business. So with that, guys, thank you so much for attending. Really do appreciate it. Thank you for your time. And again, any questions, go ahead and contact us at atgusa.com. Thank you so much, everyone. Have a great day.